Good morning, ma'am. I am Kotyada Yeswanth from Visakhapatnam, still pursuing my BTech fourth year at Vignan Institution of Information Technology. Uh, Today, I want to tell about the project I have developed in my internship, that is home automation simulation using PICSIMLab, and I have learned a lot, and I want to present a PPT, slides and simulation through my project. So going to the next slide is about what I learned in my internship programming C, and an introduction to object oriented C++ programming, and introduction to IoT and what it is, and embedded system, Arduino IDE software, PICSIMLab simulator, that is showing the simulation without any tools, using only software tools, and small projects required for final project, that is LED controlling using LDR and interfacing LCD, and a Blynk IoT integration interfacing the serial tank. Go to the next slide. About this internship is based on IoT home automation using Blynk IoT Cloud and Blynk Mobile App in the phone. The main aim of this project is to learn and expose what is IoT is and various applications of IoT. Initially, the project starts introducing to and the introduction to the C and C++ programming, and then we learned a briefing about embedded systems, and then finally about IoT, and implemented small basic project, and then the final project. So the final project in this internship is implemented using Arduino Uno and Arduino IDE and a simulator called PICSIMLab, and finally the Blynk IoT mobile application, and these all are based on IoT. So next thing, I have learned about IoT and what is an IoT. An IoT is a network of physical objects, that is things, embedded with sensors, software and other technologies that connect and exchange data with other devices and systems over the internet. So the Internet of Things is a network of physical objects embedded with sensors, software and other technologies that allows them to connect and exchange data over the internet without human input. So this device range from everyday items like smart home applications to sophisticated industrial machinery, also from our home appliances to the industrial applications, and they collect the transmit data to automate actions or provide insights. And this is the block diagram of my project home automation, that is you can see here this in the center here it is, this is Arduino Uno. It is a microcontroller, and it is the Blynk IoT app that this application should be installed in our mobile, and this is CLCD, this is temperature system. So the Arduino Uno connects to the temperature, the code is dumped in the Arduino Uno, the C++ code that is that consists of a temperature structure that what to be presented in the LCD, and the controlling of the structures of heater and cooler, and the code of the heater and code that is connected to the temperature system, and also the temperature and the notification should also have been given to the Blynk IoT app, and every instruction that is connected from IoT to the devices. As it is a microcontroller, it is a master device, so it should control this all slave devices. So this is about the block diagram, and uh, and I have gone to know some applications of IoT, that is smart home automation, like lights, fans, smart ACs controlled via phones. These all are controlled through mobile phones, and smart agriculture, Uh, this smart agriculture is also an IoT application monitoring soil moisture and monitoring irrigation, water irrigation, that according to the readings and the status in the field. So healthcare and industrial IoTs, smart cities. Smart cities refers to the smart traffic and waste management. So next one, and I also learned about C and C++, and I will tell you about what I learned. C provides direct memory and hardware access, crucial for memory optimizing performance and resources on microcontrollers and constant edge devices. And it is a simplicity and minimal overhead make it ideal for resource constrained IoT devices, where the every byte of memory and every milliseconds of processing times are critical. So the C is a basic of any language, any C language. So and very much application, and the advanced version of the C is embedded C. I had learned in the internship, and it is an extension of C, as I said, is especially designed for embedded systems, offering fine-grained control over hardware components like sensors, actuators, and custom chipsets. So the C++ is far extend of the C with object-oriented programming features, so enabling the modular and reusable code. It is very advantage for managing complex IoT projects. So like C++ offers higher performance and efficiency for the IoT devices, and the C++ allows only for high-level abstraction, simplifying the development of complex device interaction. So the purpose of the project, that is the purpose of the project is to design prototype a low-cost web-based home automation system for controlling and monitoring electrical appliances remotely. So the objectives are remote control, and it is less cost effectiveness, utilized in the affordable costs, and readily available components like Arduino and an ESP module. So learning and simulation is through the PICSIMLab as a simulation tool to test and debug the microcontroller logic before implementing the hardware, and it is an user-friendly interface also. This is the purpose of the project. So, and I also learned several components and softwares, mobile apps, and integrated on it. So coming to that, the main component I had used in the internship and in this home automation project is a microcontroller, that is an Arduino 80 mega 3 to 8p. So it is based on the 80 mega 382p microcontroller, which controls all input and output operations, and it is operated at the voltage of 5 volts using a USB cable and external adapter of that is recommended for 7 to 12 volts. So the digital and analog pins, that it has 14 digital IO pins, 6 can be used as PWM outputs and 6 analog pins, input pins, that are. So programming and connectivity is through the programming is done in the Arduino IDE software that to be installed, and via you, and as it is an online automation simulation process. So we have used a cloud Blynk app. It will be like that. So through it, so there will be a Blynk cloud, Blynk IoT cloud. In the code here, uploading, we should upload the Blynk cloud, the credentials provided by the Blynk cloud. So here we should enter it, enter the credentials, and it will redirect to the Blynk IoT cloud, and then the operation being done through the mobile app, that is switching on or switching off, as you see in the display here, the presentation, switching off and switching on of temperature system, or and switching off and switching on and showing the readings of the what is the volume of the water present in the cereal tank. So coming to that, further I learned about PICSIMLab. It is an programmable IC. The full form of it, programmable IC simulator laboratory, is a real-time simulator for simulating development boards and the microcontroller on them. So it is integrated um, and supports a variety of microcontrollers like PICS, AVR, STM32, etc., and also allows user to simulate spare parts like LED, buttons, temperature system, Ethernet shield, and many other complex components are there. User load pre-compiled code a X file into the virtual microcontroller to test and debug their project and on a virtual development board before using the real hardware. So as here in this point, I have uploaded the exe file into a virtual microcontroller and tested and debugged. So Arduino IDE, as we know, this is the software that communicate that the code is written here, or it is an integrated development environment. Contains a text editor for writing code, a message area, a text console, a toolbar with buttons for common functions and serial of menus. It connects to Arduino hardware to upload programs and communicate with them. And the version I used here for here it is not updated. I used 2.90 that version. So Arduino IoT, so as it is all integrated with an IoT devices, so I used Blynk IoT Mobile App, and about it is Blynk is a low code IoT platform that lets user build and manage connected device applications without extensive programming. So and also it is an IoT platform, handles data logging, storing and processing, and also manages data transactions. IoT data comes from many devices and locations and spans many data types. IoT platforms can orchestrate action based on real-time data and coordinate them to the long-term storage also. So it is a very large data sets. So coming to the next, this is an, as I said, this is an IoT mobile app interfaces. Okay, that should be installed through the Play Store. Now next component I learned in the internship is LDR. It is a light dependent resistor in a home automation system with IoT using Arduino simulated in PICSIMLab, serves as a crucial component for light sensitive control. So this LDR controls the garden light that in the home automation system I add and control on my garden light through the through this LDR, that is light dependent resistor. So when the resistance is too high, the light intensity is very bright and it is very the intensity is very high. So when the resistance is very less, the light intensity will be decreased. So this is I learned about this component. So LED is as we all know, an LED are the fundamental component, and it is an in our project it is a fundamental component in the home automation system. It is using Arduino, especially when simulated in environments like PICSIMLab. This serves as visual indicators for status of various applications or as the primary lightning source in a smart home setup. So LED can indicate status of the sensors on network connectivity. So in a simulated home environment with within PICSIMLab. LEDs can represent the actual lights in different rooms, that is hall, kitchen, garden, etc. Their on or off states or even brightness can be controlled through the Arduino code and the IoT platform. Next component is LCD. It is the important component in the home automation system. It is utilizing an Arduino and integrating with the Internet of Things IoT. And LCD is an liquid crystal display, serves as a crucial component for providing visual feedback and displaying system status to the user. And PICSIMLab is a simulation environment often used for PICS microcontroller. The principle of using an LCD with an Arduino remains consistent. So, and also I used in the project both the integration, the combined integration of LCD I2C. So while you are adding the component LCD component, you should add the both LCD and I2C. So here I2C means integrated circuit. So that is a very important component that allows you to connect a variety of peripherals like temperature sensor and real-time clock, LCD displays, and even more microcontrollers to your Arduino using only two serial wires. As I used only these two serial wires, that is SDA and SCL. So the Arduino can send commands to I2C slave devices, turn on, turn off, set time on RTC, and receive data from them, read temperature, get current time, get the current volume of the serial tank, like that. So in this Arduino acts as a master and the I2C acts as a slave device with the two wires, that is serial data and serial clock. So next component I learned is, this is very important component, that is this is a temperature system which consists a cooler, heater and inbuilt temperature. This is used to measure the temperature of the device. So coming to it, it is an IoT home automation temperature system in the PICSIMLab simulation, which consists of heater and cooler devices. So the PICSIMLab provides a virtual environment for designing, simulating and debugging the system before building the physical hardware. And it is very cost effective and safe environment. You can test scenarios such as temperature fluctuations in a safe virtual environment without any risk to physical devices. So coming to the next, it is the intermediate component which that is called Ethernet shield, is a very important component in my project. That helps us to connect to establish the connection between the Arduino, IoT Blynk Cloud and IoT Blynk Mobile App. So an Ethernet shield I used here, W5500 Ethernet shield is connected to an Arduino board, that is Arduino Uno. This shield provides the necessary hardware for Ethernet communication, including an RJ45 connector. That is done in well, practically. The Ethernet is connected via the internet cable to a router or network switch within the home network, and this connection allows the Arduino to communicate with other devices on the local network and if configured with the internet for remote control. So next, the topics that are covered related to IoT is in my internship is introduction to IoT, IoT architecture and its application, embedded systems, Arduino IDE, PICSIMLab simulator, working of LED and LDR, basic programming of controlling LED using LDR, about the LCD and its working and its interface, basic programming related to temperature control, introduction to Blynk IoT app, basic programming using Blynk IoT application, basic program related to serial remote time, and the final project implementation. So this is the functioning of the project. These devices are very important. That this is Arduino and this is Ethernet shield that I said. It establishes the connection between the Arduino to the complete home system. That is Arduino, the appliances that are in the home, and it this Ethernet shield will allow us to communicate this both, establish communication between these both. Next I am going to tell about the serial tank that I have used in my project. So the concept of the serial tank in the home automation using Arduino by the PICSIM is, this is the serial tank where it will show our tank is filled up or not, and if the tank is completely filled to the level, so we can outlet the water by using this IoT application by, and the main I will tell the main advantage of it and the working of it. Arduino measures the water level in a tank. If the level falls below a threshold, it activates a pump, and this level data and pump status are sent to the PICSIMLab that I had shown in the PICSIMLab simulator, which visually represents the tank filling. Uh, could also allow a user to manually control the pump or set a desired water level, sending these commands through the Arduino. So this is the Arduino IDE application. So here I implemented the C++ code and C. So this is the Blynk Cloud IoT's given credential when I registered to that app, and it is the main key. It is like a key. These three are a key, that is Blynk template ID, template name, and authentication token. So these are the libraries that I have included. So this is the structure of the cooler controlling, that is on and off. This is same as cooler. This is heater controlling. This is inlet valve and outlet valve controlling, on and off processor, that is the instruction giving. And this is structures, by using structures. So here I set the temperature limit 35. When the temperature in the device is reached to 35 degrees, it will automatically turn off. Here see, so this is the water. When the water level is reached up to the 3000, it the inflow will be off, outflow will be on. So this is the temperature readings will be shown by this code. This is the main function of the code. And also I developed LDR C++ code, exa file of LDR, and the main function exa file. And this is C++ of serial tank, and serial tank exa file, each file, and this is temperature system C++ code, and this is temperature system exa file. So by this I developed. Now I will show you the simulation of my project. This is the project I developed during my internship, that is home automation, and this is LCD, 16:2 LCD. It's integrated with I2C module with the pin numbers of 14, on the pin numbers 14 and 15 connecting it, that is serial clock, serial data. And this is LDR where I control through LDR the garden light, the brightness of the LED. So this is the temperature system, which consists of heater, cooler and inbuilt temperature, which measures the temperature. So it's the main important thing in my project, and this is also very important thing, that is Ethernet shield, which connects Arduino and IoT Blynk cloud. So this is the serial tank. This is the Arduino Uno. That is the main microcontroller I used in my project. Now I will be pairing the both Arduino and the serial tank by creating a local bridge that pair of virtual serial port. The first port as COM1, named as COM1, second port COM2, creating it by non-permanent device. So it helps to pair two devices, establish a communication between two devices, that is through of Arduino and serial tank. I am pairing a COM1 here, pairing COM2 here. It's not showing here. I will open a new tab and I will show to you. Opening a new serial tank, connecting COM2 here, and this serial tank is after establishing communication between through it, connecting through it, the water inlet valve will allow the water that is I will show you to you now. I'm connecting here, as already loaded the Arduino IDE C++ code here into the Arduino through Arduino IDE software. So we can see now we can observe the serial tank is filling with water that I switched on in my IoT Blynk mobile app. Now I will show it to you. I'm controlling in my phone. I will mirror it to you. Wait, I will mirror it. As we can see, the water inlet valve is switched on. The water is flowing into the water. I used a power mirror to screen my mobile phone to show you what I am controlling in my mobile phone. Now this is the interface of the app, that is Blynk IoT Mobile App, and I created two widgets. One is temperature system, and for temperature system, another one is for serial tank. So I will explain you about the temperature system later. Now I will tell you about the serial tank, that this I will operate it through the mobile phone. See, now I will switch on the outlet valve, so the water is flowing out from the serial tank. We can observe here, and also can observe the readings from in the mobile app, from in also in the serial tank tab. So switching on the out inlet valve, the water will be flow, as we know. So I'm switching on the inlet valve, switching off the outlet. The water is filling to the certain limit that I set as the volume, maximum volume is 3000. It will fill up to the 3000, see there, and it will automatically switch off. See there, in the inlet valve, switch off the button, switch. So I have developed it in the C++ code, run it through C++ code in the Arduino IDE, and observe the readings in the both tabs in the IoT app and also in the serial tank. Now I will be tell you about the camera system, how I controlled through my mobile IoT app. So this is through the LCD. I can know the how the inlet valve is on or inlet valve is off. So this is LDR, we know, as I said, it controls the lighting. When the resistance will be decreasing, the light will be intensity will be less. When the resistance is increased, 100k resistance, the light intensity will be very large. You can observe there. And through Blynk IoT app and also through LED, when I switch on the cooler, see, I can see the readings there in the LED, and I also see the readings in the temperature system. When I switch on the heater, the temperature will be increased. See, heater is on, the temperature readings also can be seen there. As a temperature, and also I developed in the code C++ code that when the temperature is increased to the 35 degrees, the heater will be automatically switch off. See, you can observe that when the temperature increased to its maximum, the heater is switched off. So it is developed in the code. Now I will switch on the cooler. See there, I can see the cooler is on, the temperature is reducing into the home. So this application is used in a smart home, and it is using in nowadays home. So it helps me to learn a lot from this simulation, that I can control anything through my mobile phone. So finally, the project conclusion, the C and C++ Arduino internship program was a learning experience that provided both theoretical and hands-on exposure to fundamental programming and embedded system concepts. Through the sessions of C and C++, I developed a strong foundation in programming logic, data types, control structures, functions, pointers, and object-oriented programming. So this rapidly increased my confidence to for the problem solving, for the real-time systems also. The Arduino and IoT modules added immense practical values by bringing the gap between coding and real-world application. Interfacing various sensors like temperature and LCD, working with Arduino and Blynk IoT Mobile App, Blynk IoT Cloud, and hardware software interaction and IoT based project implementation. So this project has helped me for boosting my confidence in problem solving, debugging, and designing complete embedded systems and IoT, and gave me understanding how the IoT works in the nowadays home, and how it makes as very useful and advantage for the humans and the future generation. So thanks ma'am for giving me this opportunity